Good afternoon, everyone. My name is Jenny Simonson. I work for ITS Norway. I was very proud to host this webinar today. And for our partners, Aventi and Kapsch, and we have some distinguished guests with us to talk about road user charging from their perspective. We have Transport Economical Institute, TØI. We have Einar Gotas from Drivkraft Norge. Do not know how to translate that one. That you probably know better than me, Einar. And then we have Ørjan Tveit from the Norwegian Public Road Authority, Statens vegvesen. We will record this webinar, as I said initially, and share with you on our website. If you would like to have it sent to you directly, please send me your email. I will add my email in the chat, so you can directly send me an email, and we will share the presentations and the recording with you directly as well. There we go. We have time for questions and answers. I had the agenda up there for a second. I will share it just with you quickly before we dive straight in. We will have a quick break at 2:30 in order just to do some technical break, and then we'll continue with presentations from Aventi and Kapsch. We have, as I said, some time for questions and answers. I would wish and would like you to, when you have a question, raise your hand or write it straight into the chat. We have used the chat quite frequently before, and it works quite well. We will ask the presenters or anyone else feeling that they have the right answer to answer those questions. So we do hope that you take the chance to ask the question when we're in this webinar. So without much ado, I would like to just drive straight into the first presentation by Paul Brevik from TØI. Paul, hello, and please share your presentation.
Do you see?
We can see. Thank you.
Great. I guess I got some bonus time by starting this early. All right. How will GNSS-based road use charges change the cost for people and the income for the government? So this will be from the perspective of a transport economist. I'm not very the technical aspect I do not know much about. Other of our presenters will take care of that. But the economics side of it I will cover, and mostly go through the principles. There we go. So let's start just with a little context. So there are some recent developments in Norway where you have our current government that have stated that they want to design the tax system such that it is fair and contributes to cutting carbon emissions, and consider solutions that could replace road tolls in the future. Because Norway is a country of road tolls for those who are not from here, and its coverage nationally has increased manyfold over the last decade. So there's been a policy process that has led us up to this point. Both the Labour Party and the Centre Party included road pricing in their party platforms of 2017. And there was a proposal from Parliament to study the potential for road pricing to replace road tolls in 2018. The Parliament made a decision in 2019. And then the Ministry of Finance and Ministry of Transport gave the order to the Norwegian Public Roads Administration and the Norwegian Tax Administration to do the study in 2021. And that is the ongoing concept selection study, the KVU for road pricing that Ørjan will talk more about later. So the context, I would say that context is from two angles: the revenue part and the general efficiency of the current system part. So the revenue part, vehicle tax revenue is high, but it's dwindling. So you see it peaked in 2012. Yeah, so yeah, it's the revenue, the car revenue tax, the tax from fuel, CO2 component, and the road use component, the registration tax, the re-registration tax, the annual circulation tax for trucks and passenger cars, and then the big one, the one-off registration tax, the tax when at purchase of a new vehicle. And that tax is a function of weight and CO2 and NOx emissions. And as the CO2 emissions per kilometer has dwindled throughout the last decade, so has the income from the one-off registration tax. And then you have tolls, which have somewhat increased over this period. And in 2012, this revenue amounted to 11% of government consumption, and in 2018, it was 7%. So it is dwindling because we're getting results regarding climate. CO2 emissions and fuel use per kilometer is rapidly falling throughout the last decade. And since fuel taxes and the registration tax is a function of that, therefore revenue is falling. So the tax is doing what it's intended, but that means you lose revenue. And a familiar graph, the growth in electric vehicles. That is the main driver of why these revenues are falling. So the share of electric vehicles was more than 60% last year and was close to 80% so far this year. And we have passed 500,000 electric vehicles in Norway. So this is what policy wants, but it is costly. So that was the revenue part, but it's also a question of the general economic efficiency. So for economic efficiency wants the tax to match the marginal damage cost of driving. What is the marginal damage cost for driving? It is the sum of CO2 the value of the CO2 emissions, the value of the local pollutants, because of health costs that they cause, noise pollution, also a question of health costs, and congestion, the time loss, the inconvenience, and accidents, also a major cost, and then road wear on top. So in the ideal system, you want the tax to match these marginal external costs that vary by car type because of their emission standards, and by area. You want to charge less in rural areas because there's less exposure. Fewer people are exposed to the pollution and there's less congestion. And then you want to have a higher tax in the cities where there's more exposure and more congestion, in particular in peak hours where the congestion is at its highest. So if you manage to tax the marginal social cost, you achieve the economic efficiency. And this is something that economists have been talking about for 100 years, and it's starting to sink in. So let's have a talk about costs and revenues. So to answer the question that I was given, how will GNSS-based road use charges change the cost for people and the income for the government? Well, that depends. Apologies, I am an economist. That is how we usually answer questions. It depends on the revenue target that our policymakers will set. They are free to do so. And the pricing structure, which they're also free to set. So the total road user charges paid will depend on whatever revenue target the government sets. It can be modest, it can be large, or it can, be precise to maximize economic efficiency. So this could include precisely matching the tax per kilometer with estimated marginal damage cost per kilometer, no more, no less, or simply recovering the current fuel-based road user charges. It could also aim at recovering current fuel-based road user charges and the tolling revenue, or they can go all in and make it basically recover almost all revenue from cars. So the fuel-based road user charges, the registration tax, the annual circulation tax, and the tolls, all baked in to cost per kilometer that all drivers will pay. So the annual bill for a given car owner will be paying road user charges will depend on the revenue target and the pricing structure. So the road user charge could be set at a flat rate per kilometer. That would be the easiest to implement and monitor, but it will do a poor job in making drivers internalizing the social cost of driving. Or they can do what economists like, that they could set to match the estimated marginal damage cost per kilometer to vary by car, the emission standards. Old diesel car should have a higher kilometer charge because of higher NOx emissions. Area, urban versus rural, more higher charges in urban areas, and time of day, so higher charges in peak hours. So this will do best job in making drivers internalize the social cost of driving, but it could get technically, legally, and privacy-wise complicated as it requires sophisticated technology and detailed monitoring. And some of the other speakers will get back to this. The road user charge could be set to reach a given revenue target with rates adjusted in proportion to some measure of social cost per kilometer. It will not be as simple as a flat rate, and it will not be as efficient as rates matching marginal social cost. So further analysis will be needed to see what this animal should look like, if that is indeed what the policymakers want. So let's discuss some of those options. So simply recovering fuel-based road user charges with a flat rate. So the road user charges has an annual revenue of about 14 to 16 billion kroners in the period 2015 to 2021. So it's a sizable chunk of money. So if you implemented this flat among passenger cars, the current proportion for passenger cars, it will be about 0.4 kroners per kilometer per car. So maybe you would implement this for only electric cars, and then fossil car and internal combustion engine vehicles would then still pay at the pump. Could be, but that would be roughly the area where you would be. So once electric vehicle drivers pay per kilometer, they will pay a lot more than they do today, which is close to zero. And yes, the question, should it also replace the road user charge at the pump? If that is the case, then we can start discussing who will pay more. We know electric vehicle owners will pay more, but less efficient internal combustion engine vehicles would pay less than they do today if you take away the kilometer rate that is unrelated to fuel usage, that you just put in some average. You will have an incentive to economize kilometers, but not fuel use. Often they correlate, but a less efficient vehicle would previously pay a higher rate in order to economize fuel than they would on a flat rate that is aimed at the average. And more efficient internal combustion engine vehicles would pay more. So yeah, that is definitely something that the concept study I know they are grappling with it. Yes. So recovering the current fuel-based road user charges and tolling revenue with a flat rate, then the annual revenue is about 25 to 27 billion kroners per year in the period 2015 to 2021. Huge chunk of money. the change away from the fuel-based road user charges would have the effects in the direction discussed in the previous slide, that you would economize kilometers, not fuel. Electric vehicle owners pay more. But if the toll revenue is linked to financing of road projects and city development packages, it could cause some messy road user charging that let's say you have a flat rate throughout the country, and then you add a tolling rate on certain stretches or in certain parts of the city that is related to financing and not to the external cost. That is a tricky issue that also I know that the concept study is grappling with. But one thing that it can't be stated enough, that moving from point-based to kilometer-based tolls, you get the good principle, those who drive more, they pay more, and you avoid the arbitrary payment that those who have a short trip, starting from just outside a tolling point to just driving just inside the tolling point, pay a huge cost per kilometer per average than someone driving a long trip crossing the tolling point, where they pay the same lump sum, spread it out over across kilometers, but the ones who drive more pay less per kilometer. And that is just arbitrary. And yeah, economists, many of us try to refrain from discussing fairness, and fairness has many dimensions, but this is definitely one of the most clean-cut improvements in fairness, that you remove this arbitrary issue of paying a lot for a short trip that just happens to pass a tolling point. It is a lot more fair to pay in proportion to how much you drive. All right. So if they go all in to make the road user charge replace current revenue from fuel-based road user charges, registration tax, annual circulation tax, and tolls, then we're talking annual revenue of 45 to 55 billion kroners in the period 2015 to 2020. That is a lot of money. And the change away from fuel-based road user charges and tolls would have effects in the direction discussed in the previous slide. And yeah, so replacing the registration tax and circulation tax would require more than 20 billion kroners in extra revenue compared to the previous slide. That would be spread out across kilometers driven. And who is getting off the hook? Those who want to buy a new car. So those who drive more, they pay a lot more. Those who wish to buy a new car, they will also, they will pay less for the car. So all drivers pay more per kilometer. So the obvious winners are especially those future multi-car households, those who own cars but not necessarily have a high utilization rate per car. So it rewards stocking up and not use. And the obvious losers, those who drive a lot, who already had a car where they already had paid the registration tax. Yes. And since the registration tax is one of the main drivers in making the Norwegian car park look the way it looks, because it so severely punishes weight and CO2 emissions. And if you just remove that, the pricing structure for upfront car purchases will be so different that you can expect fundamental changes in the composition of new car sales. So what the economist likes, precisely matching the tax per kilometer with estimated marginal damage cost per kilometer, no more, no less. You want the tax to match these bar charts, vary it by car, by area, and by time of day. So some extremely rough calculations indicate revenues of about 50 billion kroners before equilibrium adjustment. So this is just the naive taking the rate that me and my colleagues documented in our report on external costs and multiplying it with kilometers driven by gasoline and diesel cars, electric cars, trucks, buses, etc. But once you introduce prices, people adjust, and we can be sure that even if this was the correct value of external costs right now, when they adapt, it will be lower. In particularly driving in the cities, especially during peak hours. Once facing that cost, they will adapt and drive less, which is exactly what we want with a tax that is meant to internalize damage costs. But it means less revenue. Exactly what we've seen with the car fleet with electric vehicles. You get what you want, but it does cost in foregone revenue. You might get somewhat more driving in rural areas because the average diesel and gasoline car pays more in the fuel-based road user charge than they would with an average road user charge that matches marginal damage costs. But in some, we can expect them to pay a lot less. But the winners of such, the obvious winners of such a scheme would be those who drive most in rural areas because they get cheaper kilometers. But many of those who drive a lot in cities will lose out due to more expensive kilometers. But there's a twist here. Some city drivers with high value of their time will gain due to curbed congestion. So high income drivers, but also in particular professional goods traffic in particular would gain because they the value of the goods that they are transporting, the value of time is so high that reducing congestion would likely more than outweigh the cost of higher road user charges. And people vulnerable to pollution will gain. And once you sum up, society is expected to gain just because you have made the system more efficient. And even if you don't do anything useful with the money, you just give it back to citizens, society is expected to gain. So, and then the in-between, aiming for a revenue target by scaling kilometer rates proportional to estimates of external costs. Not as simple as a flat rate, not as efficient as matching marginal external costs. And the optimization problem changes to how to raise revenue at lowest social cost and would require more specified transport modeling to find some reasonable solutions. So, why transport economists love distance-based road pricing based on marginal social costs. And yeah, this is just economics 101. You have a social cost that is higher than the private cost. And if it's not taxed, you have too much driving, and that represents social loss. If you tax it, you reduce driving so that the willingness to pay for driving matches the social cost of driving. So it's a right sizing. And that is economic efficiency. You maximize the social surplus. So what characterizes this social optimum is that the social cost of driving and the private cost are aligned. And there will still be plenty of driving. This has nothing to do with anyone saying that, oh, there shouldn't be any driving or you want to tax away all driving. No, it's about adjusting so that there will be those car trips that cost the most to society and give the lowest benefits are priced out. Those with the lowest benefit cost ratio are priced out. So it's about right sizing the transport volumes and the policies are beneficial, even if it's delivered as a lump sum back to citizens, but additional benefits can be made if it's part of a broader tax reform. So which taxes should road pricing replace? It could replace several vehicle-related taxes, mainly those that are already either use-related or annual. So the road use component of the diesel and gasoline tax, the road tolls, the traffic insurance tax, or the circulation tax that I called it earlier, weight tax on heavy vehicles, and the environmental tax on heavy vehicles, along with ferry tickets. But not replace the CO2 component of diesel and gasoline tax, because CO2 is directly related to the fuel consumption. It's far more precise to tax it directly. And the purchase tax should probably not be affected by this, because in the short run, it is proven to be a highly potent climate policy instrument, and removing this right away would probably not be a good idea. Benefits to the private sector. With the road user charges, you have stable and predictable transport costs, particularly if you link it to credible estimates of marginal damage costs. You have a more precise tax system. Everyone pays, no competitive advantage depending on where you are. And revenues can be used to reduce other taxes. And you avoid the high and arbitrary road tolls in rural areas that are bad for commuters and for freight transport. And time loss and congestion is particularly costly for professional transport. So price away a lot of the congestion, and you free up a lot of value in society. So how to get there? It's off to a good start with the well-planned KVU. And do not let the best be the enemy of the good. Even if it's not optimal now, it can get closer to optimal later, but you need to build the fundamentals. So maybe before throwing away the fuel taxation and other taxes, maybe try to get it right with electric vehicles first, which currently now are close to zero in taxing. And you want to avoid the Dutch case, because they tried to get a national road pricing scheme up and running, and it looked so promising. It's been on the agenda since the 80s, through the 2000s. They had a commission. They had a huge planning project, and they had the financing. Cost-benefit analysis concluded that the project had positive and substantial expected benefits, and then it failed. It was sent for discussion in the lower house, but it coincided with a government crisis over Afghanistan. And in all this chaos, the lower house declared road pricing for controversial. And there was a new election and large changes in the party composition in parliament. And the new government withdraws the Dutch Road Pricing Act. So that is something that we want to avoid in Norway. So needs to be built on solid fundamentals. So to sum up, how will the road use charge change the cost for people and the income for the government? Well, a public official can choose from a broad range of revenue targets. So it depends on how greedy or precise they choose to be. So the transport economic literature would tend to recommend focusing on getting the prices right, and the revenue target would be secondary. So the biggest change related to getting the prices right is that driving in rural areas will become somewhat cheaper, and driving in urban areas will in most cases be more expensive. Getting the prices right will improve efficiency in society, and it will improve fairness in some dimensions, in particular avoiding the arbitrariness of tolls. But if some groups are worried about the welfare of some groups, then don't mess with the prices. Have supplementary policies in order to assist vulnerable groups of this system. That is basic economic wisdom. All right, thank you for your attention.
Thank you so much, Paul, for that. The lesson is to try to avoid the Dutch case, right? Any questions from the audience? You now have a chance to ask directly. We have a question in chat, and we have a raised hand. I will take the question from the chat first. If overall traffic revenue decreases, what are likely consequences? Will the reduced revenues be sufficient to sustain the existing infrastructure?
That is up for discussion. It depends on how. Well, with the current, they are likely to get in more revenue than what is currently used for tolls. So you can replace tolls if you want to, but most car-related taxation goes into the general budget. So it's a question of prioritization.
Okay, Sverre, you have your hand raised, please.
Yeah, sorry, I was a little late to the party, so I only got the ending here, and it provokes me. You said that you're going to remove the traffic that cost the most with the lowest benefits, correct?
Well, that is
Who determines the lowest
incentives. That is up to the driver itself to weigh the costs and benefits of any trip. And
no, it's up to the government. My daughter has horseback riding in rush hour traffic. That means her benefit will be perceived low because it doesn't have any social value. So I will have to pay a steep price just because some bureaucrat says that driving in rush hour should be more expensive.
You decide what the value of taking your daughter to horseback riding is. If you think it's valuable, then you will pay the price, even if you call, and then you pay for the congestion.
Okay, you're going to price away congestion, correct?
I think this comes back, Paul, to your initial comment when Sverre, you weren't here. Unfortunately, it was about fairness, and I think that's comes into the question from the fairness. I will also send the presentation as you weren't in the beginning, Sverre. So you will receive the presentation if you send me your email. My email is in the chat, so please send me your email, and all the presentations in PDF forms will be shared.
Mm-hmm.
I will. There's a question from Marco from ITS Finland. What is it?
I have one more. Can I have one more?
Very short ones, Sverre, because we have
public official can choose revenue targets, correct?
Yeah, that is up to our elected officials.
I'm sure that's what they told them when they introduced the power lines to England as well, that this is going to be a great benefit. As soon as there's a new crisis, this is going to increase prices. So I'll be driving a T-Ford without this GNSS thing. Thank you. But I look forward to receiving your PDFs.
Thank you, Sverre. The question from Marco was, what is the cost of collecting taxes by, I guess, our road user charging, comparing the current cost collecting taxes through gasoline pumps?
That is also subject to the study, the ongoing concept study.
Okay, very good. I don't think there's an English version of that concept study yet. I think it's only in Norwegian. Thank you so much, Paul, for that. And we will move on with Einar Gotas from Drivkraft Norway. Why CO2 fees should still be charged at the gasoline pump. So if you, Einar, can share your...
I'm trying to get it up right now.
Good.
There you go. It should be up right now.
Excellent. It's coming up there. Thank you so much.
Thanks. Thank you very much. Paul, very interesting to listen to your first introduction here. I'll probably come into some of the same points, but that's how it is. First, a few words about Drivkraft Norge. It's named Drivkraft Norge at English because we don't have an English name yet. In Europe, it's called more, maybe it's Fuels Europe. That's our sister organization in Europe. So if it should be anything in Norwegian, it probably would be Fuels Norway. We are an association that represents the interest of fuel and energy companies in Norway. Our members cover about 95% of fuels sold to road traffic in Norway. And we have ambitions of reducing our CO2 emissions from our products by 45% in 2030 compared to 2005, and to be carbon neutral in 2050. So we have to really get renewable fuels to phase out the fossil fuels. First of all, I just want to show you a diagram of emissions from road traffic. This is how it has been since 2000. The blue area is the actual CO2 emissions from road traffic. And the colors above is the reduced CO2 emissions from using biofuels, electrical cars. And the black line is where to be at 2030. So we still have a long way to get down to the black line. The CO2 emissions are, as said, it's perfectly correlated to use of fossil fuels. This is a prediction by TUI. If we are getting the target right for phasing in zero emission cars, you will phase out the use of fossil fuels, and phasing out fossil fuels, the CO2 emission will be reduced. The CO2 tax in Norway, it was introduced in 1991. The main objective is to put a price on CO2 emissions from the use of fossil fuels. So, and of course, high tax will phase out or will stop or reduce the use of fossil fuels. It might reduce the use of fossil fuels. Right now, it's more or less a flat rate for CO2 tax on emissions. You can see there we are heading for a 2030 target of 2,000 Norwegian crowns per ton. The government has just made a proposition on having it up to 952 kroners per ton CO2. As you can see how it would be for the gasoline and auto diesel for road traffic, the CO2 tax. And of course, there are no CO2 tax on biofuels or other renewable fuels, since it's not from fossil fuels. And as Paul talked about, the need for income for the state, you can see on the left side here, where the veibruksavgift or road use tax is shrinking. In fact, the CO2 tax is rising, but more because of having higher tax on per liter. It will of course turn around at some point, because at the right side you can see, as Paul said, new electric cars is about 80% of the sales right now, and if it continues on that and going to 100%, of course the sale of fossil fuel will shrink and fall, and then the CO2 tax will fall. So why keep the CO2 tax at the gas pump, as I was told to talk a little bit about? We can't mix the CO2 tax and the road tax. The CO2 tax reflects only one element, the CO2 emission. Emissions is perfectly correlated to how much fossil fuels are used. It has a global impact. It's independent on where and when you drive. The road tax, veibruksavgiften, reflects 5 elements. It reflects accidents, congestion, noise, road wear, and local pollution. And these are not correlated on how much fuel you use. And it has local impact depending on what, where, and when you drive. So the CO2 tax and the road tax is completely different. So you can't mix them, and you shouldn't mix or you shouldn't pull the CO2 tax from the gas pump, because it fulfills the polluter pays principle. It's very effective, the system we have today. It's only fossil fuels are taxed when you buy it. It's cost effective. Tax is brought in by our members, just a few companies, instead of from the end user. If all end users were supposed to get the road tax, it will be a different way to do it. It's easy to control and to predict, and to then, if you don't have and the end goal is no CO2 tax, since we don't use any fossil fuels. So it will be phased out, and it's a final goal to phase it out. So then they have to find the income in other ways for the Norwegian government. Thank you.
You were so quick there, Einar, with your ending that you almost caught me there. Thank you so much. Is there any question to Einar? I still have a couple of minutes. So did you disappear, Einar, or are you still there? Well, it looks like he disappeared.
I'm back.
Oh, you're back. Sorry,
I pushed the wrong button.
Yes, that happens to most of us, actually. Any questions to Einar? I think you have to leave, so you were not able to stay for the whole webinar. But if there are any questions to Einar later on, please don't hesitate. We can forward them to him as well. So thank you so much for your time, Einar, and
Thank you very much.
have a great afternoon.
Thank you. Bye-bye.
Bye-bye. Then we have Ørjan Tveit from the Norwegian Public Road Administration. There you are, Ørjan. If you can share your presentation.
Yeah, I can try. Let's see.
Excellent. Thank you. The floor is yours, please.
Thank you. I've been asked to say something about road user charges and tolls, and the Norwegian government's concept selection study, and how Kapsch and Aventi solution fits within this. So that's what I'm aiming for today. Firstly, a little background. The Ministry of Finance and the Department of Transportation have commissioned the Norwegian Tax Administration and the Norwegian Public Road Administration to carry out a concept selection study regarding the principle of determining and collecting road user charges and tolls. Let's start with the current situation. Fossil fuel cars will pay road user charges at the pump. I think that's been pointed out quite clearly previously. And they also pay tolls a normal rate in toll rings and toll projects, while zero-emission cars are not paying road user taxes to the state, and they also normally pay a lower rate in toll rings and toll projects. So that's the problem that we need to address. As has been pointed out previously, there's a reduced income from the road use tax, and it's going from something like 18 billion Norwegian kroner per year to let's say 8 in 2030. So it's going to be a huge reduction due to electrical cars. And these external costs that are not addressed now is accidents, queues, noise, road wear, and health and environmental harmful emissions. So we still need to address those issues. The project that we are a part of, the COVU, is trying to set up its goals, and the community goal is that the initiative will ensure accurate and sustainable pricing of road use and financing of transport projects. So it's focusing on accurate, both the road user are faced with prices that make them take into account the inconvenience that the use of vehicle causes others, in line with the polluter pays principle. This faces with payment with a utility principle, and also we are looking into sustainability, financial, ensure that the possibility of locally rooted toll project and stable income for the state, and environmental influence behavior that promotes more sustainable mobility. I think this has been addressed before, but a little bit more about where this core review is currently. We have started a conceptual selection study, and we are quite near the end of that. We are going to deliver our study within a month, and then there's going to be a cabinet decision whether should we go on to a pre-project. And what are we proposing? What are we saying? The concepts that we are focusing on is, of course, you can keep on going as we are, or we can have a concept one where we have a distance-based payment for electrical vehicles. The new road user charge only applies to zero-emission cars because they are not currently paying at the gasoline or petrol pump, while fossil cars still pay there. Zero-emission cars should report mileage automatically. We are discussing manual reporting for zero-emission vehicles that do not have an integrated option for automatic reporting. The concept can establish good solution for registration of mileage and payment, and the concept has flexibility, allows for a gradual transition from manual reporting to automatic reporting for a larger part of zero-emission cars. What we see is that we are currently in a situation where a lot of the electrical cars actually have a back office solution where they are reporting how long they have been driven the past day, week, month, year, and it's possible to get the information from there. And that's the basic for what this concept would be focusing on. So it's focusing on getting the zero-emission cars to pay road user charges to the state, just dependent on how many kilometers they are driving a period. But as we heard previously, this is not the best solution to focus on polluters paying. So it will not reduce the queuing so much. The second concept that we are discussing currently is it's a new way of setting up so that you are paying a different toll with rural and city driving. So you're just sharing or dividing by those two areas. The new road user charges applies to all cars, so can be introduced gradually for fossil cars. Over time, it will be unfortunate to have a two-price system that only applies to zero-emission cars and not to all type of cars. Of course, in some content, you can say that fossil cars are using more petrol and gasoline if they are driving in a queue. So in a way, they are paying more when they are in a queue situation, but perhaps not in the way that we would like to. in this concept, there's a need for data that reduces the number of kilometers driven and connects this to a certain zone, hence the number of kilometer driven in a city and the number of kilometer driven outside the city. There's no need to record detailed data about where the car has been driven or on which road it has been driven. Data can most easily be obtained by GNSS, and there is some of the problems because then you normally would have a lot of information. It will increase the socioeconomic benefits in both toll collection and determination of road user charges that have common data collection. We can have automatic reporting of distance traveled. Not all cars will have built-in equipment that is able to automatically report the necessary data. Then, until all data have an integrated vehicle unit, it will be necessary to install extra equipment in the cars. This example actually requires that you have some sort of device that could measure where you have been, which zones you have been in, and you're sort of just taking out the minimum number of minimum data amount that is possible. So you're just saying, are you inside or outside the city center? And you can still pay tolling as we have done previously. The third concept that we are looking into is more like a new road user charging for all cars. And in principle, we can discriminate between three geographical zones, where zone 1 is rural, that's sparsely populated, and we do have a lot of that in Norway. And zone 2 is small city, where in statistical official Norway statistics, we can say that if you are below 100,000 in the city, that's a small city, and above 100,000, that's a urban major city in Norway. Gradually, more cars will have integrated equipment to be able to report necessary data automatically. This will still take time, and the oldest part of the car fleet must be allowed to install extra equipment in the car. The concept can have flexibility and open for gradual transition for fossil cars. So that means actually that every car needs some sort of device that tells it where it has been and when it's been there, so that we can measure the number of kilometers driven in different zones and in different time slices, so that you have perhaps a different price in the rush hour compared to the non-rush hour. The concept selection study consists of several topics besides the technical solution, like organization, regulations, pricing model, user group, political considerations. I'm certainly not going into that. But the question that we are asking ourselves is risk. Should Norway be a first mover? The number of electrical cars may indicate so, but it's still an open question that we would put forward to the political debate later. So what we have currently is that the zero option is that oil companies that are taking in road user charge or veibruksavgift for 14 million kroner currently, and we are having tolls for 12 million. In the first example that I showed, where we just have a flat rate for electrical cars, we have estimated that it can come up to 18 million kroner in road user charges. But this is, of course, something that we had to consider how the traffic will change when you put on new ways of taxation. The second concept, where everyone had to have some device or some way of deciding where they have been, and you can divide it in 2 zones. This concept would make be responsible for 18 billion kroner each year, and in the third concept, this concept will take something like 30 billion kroner each year in revenues. So then it will be really a high cash flow in these concepts. I have also enclosed here an optimistic schedule for the discussed concepts. It's in Norwegian, I'm sorry for that, but it says that if the concept 1 is just distance-based road user charging for electrical cars, it could be utilized, or it could start in 2027. If we look at the concept where we are dividing a city and the county, and then all vehicles must have some sort of registration. We are talking about 2030 as a full employment of this concept. And the third concept, with more like a road pricing concept, the first or optimistic schedule would be in 2031. So first mover is not next year. It's still some time to do it. And then the question is how Kapsch and Aventi's solution will fit with this schedule, this way of thinking. And before I can answer that, I have to go a little bit back, because in Norway there has been many press releases about potential changes. Our Prime Minister has been saying that he would like to tear down the tolling stations and change it with road pricing. But we need more knowledge and facts in ongoing debate on position-based user road user charges and tolls. So the Public Road Administration has, together with especially SINTEF and Q3, had some research projects. We started in 2018. The intention with this research project is to clarify if the technology solutions are recommendable. Can we provide knowledge about user experience and attitudes to this concept? That's also something that we are looking into. And the research project that we had initially has been forced a little bit and expanded to answer issues that the KVU has had, because we would like to look at more than just the core technology here. So there's been a test in Trondheim this year, where we have a pilot with OBUs installed in cars, and we were assessing the maturity of road pricing technology. We have been focusing on reliability, driver interaction, user acceptance, privacy, and data processing. I think that one of the interesting thing or special thing is GNSS. It's not as easy as you might think, because distance traveled in this concept were logged by GNSS movement and not connected to the road network. Tunnel, bridges, and ferry connections were especially identified, but the distance traveled together with geofence zones formed the basis for the position-based road user charging. We had a local storage would only transfer of payment information, and we follow the data dietitian's recommendation and get it back. And we can reuse much of what we have currently. One interesting thing is the questionnaire for the participants of the survey. After testing distance-based tolling in Trondheim, the participants are mainly positive to the concept. One question that we asked them in the questionnaire is, to what extent would you say that road pricing would be a fairer toll system than the current toll system? And I think that the figure shows quite clearly that people were quite positive to that, to have distance-based road pricing. But one of the more perhaps not so obvious things is that people also would entrust a third party to protect data. And that's quite important for the topic today, because even though some are really not into it or do not like it, a lot of people accept a third party solution. And perhaps that is something based on that we are using mobile phones, we are using different electronic devices that are sharing information about us anyway. The number of participants in the study was meant to be 200, but we ended up with something like 135. We had some extensions that I was talking about previously. We have a solution where we are integrating the concept in Polestar, where we are using Polestar as a platform for the data that we are currently having in the OVU. So that's more like the same. And we are also following this concept that TAV, Aventi and Kapsch have developed together. And I think that one of the things that we have learned, and I think is important, is to focus in is that a thin and a thick client can give quite different possibilities. A thin client transfers all GNSS position to a central data solution where map matching is used with updated maps. This means that you can also price different road types differently within one area. A thick client means that all data is locally stored, and it's challenging to keep up-to-date maps and price metrics stuff in all units. So it's easier to use geofencing to say, if you are inside this area, you are paying this price, and if you're outside, you have another price. I think that it's fair to say that it's quite a lot of interest for this topic currently. The Public Road Administration is involved and have some experience with 3 different projects that are focusing on different technology. GeoFlow, that was mentioned previously, are using our onboard unit. Aventi is using a mobile phone and both are based on GNSS. And we also have some a project where we are trying to use 5G net as a way of tracking the vehicles. We haven't succeeded there yet, but I think it's important to follow different possible technical solutions so that we don't recommend something that seems good today and 2 years down the road something new pops up. So that's why we are looking at different solutions to see where can we find the best way of moving forward. So if we are looking at the propositions that I was talking about previously, I think from a technical point of view, we need at least some sort of equipment or setup in all cars if we're using road use detection 2 zones from a technical perspective. So that means that we recommend a setup where user could choose technology that suits them. And the recommended technologies that we are focusing on is an OBU, an integrated solution in new cars, and an app in a smartphone. And all these are possible ways of detecting where you have been driving, and we can take out the required information to see if we have been driving in a rural area or in a city. And we can have both a thin and a thick client, and that means that it's also possible for people to choose themselves. When it comes to road pricing solution like that in alternative 3, we still recommend the same thing, same setup, the same technologies, and OBU, integrated solution in new cars, an app and smartphone. But we are now taking out a lot more information from the units or the registration registration units in the cars, and that's something that it's both challenging and perhaps also gives a lot of possibilities. Possible next stage, that is, after the conceptual selection study has been delivered, it's up to the cabinet to make a decision. Should we move on? Should we follow up on what we have previously said, just in our in the way that we have set up our policies? Should we follow through? And then, if the answer to the question is yes, then it's going to be a pre-project where we have to focus on what we have learned in the conceptual selection study, and that is we have to look more into GNSS vulnerability. We have to look more into enforcement, and the implementation strategy should be decided whether you should have a thin thick client or if you should have an optional, or it should be optional. And we also need to address if we should include all 3 platforms that I've been briefly describing here, or if we should focus on perhaps 1 or 2. And that's what I intended to share with you today.
Thank you so much, Örjan. There is a couple of questions that we could start with. Are you considering dynamic pricing for peak hours in urban areas?
Yes, we are considering it, but we are more like putting up the options, and then it's not up to us to decide whether it should be done. So we are putting up the possibilities and describing how they could be perceived and the pros and cons with the different ways of putting it up, and then that's why it's a conceptual study, and perhaps not a conceptual choosing or recommendations.
I just like to turn back to the first question that was about the infrastructure, and if there reduced revenues, how will that impact to keep the infrastructure in the same level as now? Have this concept study, do you look at the infrastructure and keep that in mind as well?
We look at both cash flows that are currently we have currently, as I said previously, both the tolling in and toll booth or toll rings, and we look also at road user charging that we have for electrical cars and so on. We know that if we impose a new taxation, there's going to be some alterations in the traffic flow, and that's also something that we look into and model to see how will people react most probably, and how will that affect the income for the state and the possibility to, as you say, uphold the infrastructure and even invest further in infrastructure.
I was recently with a larger group in Phoenix, Arizona, and we test drove the Waymo robo taxis. So if the future would be filled with the more robo taxis also on the Norwegian roads, would this study, the conceptual study, be able to take that as well into consideration and see how that? Have you had any thoughts about it?
I think that's a really difficult question because when will this happen and to what degree will it happen? I think that
as well.
I think that we need to focus currently on the development that we are certain about, and then if we have a large changes as you are mentioning now, that's something that we have to look into at a later stage.
Are there any more questions to Örjan? There is a possibility to ask him 1 or 2 questions more. He will also stay for the end of the presentation where we will have, at the end of the webinar, we will have a little bit more time also for Q&A. But as we see that we had some time, it's a great possibility to ask the man of the hour some questions while he's here. And if not, I thank you so much, Örjan, for your time. And you will stay on for if there are questions in the chat. And I will then give the word forward to Justin Hamilton from Kapsch. Welcome. And the floor is yours. Please share your presentation.
Thank you very much, Fanny. Let me just bring that up. And we'll go in presentation mode. Okay, everyone can see the presentation?
Yes, we can.
Very good. Okay, so good afternoon and welcome from a very sunny and wonderfully autumnal Vienna. I'm given the privilege of starting and taking everyone through some background and introduction to our road user charging proof of concept in Norway, the JuztDrive POC as we called it. And look at that, we're right on time. So what I wanted to do first is give you just a little bit of background to the wider European context. There's been a lot of discussion in previous presentations around the use of GNSS for any potential future road user charging scheme in Norway. So I wanted to take a quick look at how that is progressing across the wider European context. If we look back in time a little bit to 2018, we will see that at that point, it was really a bit of an emerging technology in use primarily for, well, almost exclusively for heavy goods vehicles and really in a handful of countries. Germany, of course, has implemented this for quite some time. Other countries like Belgium were quite new to the technology. And then we had others like Slovakia and Hungary that had come on the scheme, introduced GNSS, and then Poland that was due to do so shortly. If we fast forward to today, what we see is that the number of countries using this technology, again, mostly for heavy goods vehicle schemes, has grown. Poland has introduced the scheme, and that's now live, running across the country. Czech Republic also introduced its own GNSS scheme roughly 2 years ago. Other countries like Belgium as well have entered. Some of them continue to use vignettes as well for light vehicles and what are called local tolls, which might be a small isolated bridge or tunnel toll. But in many cases, these are now used nationwide. And if we fast forward another 4 years, how do we expect that landscape to change? Well, we already know that countries like Denmark, just across the water from Norway, have plans to introduce a GNSS scheme of their own, again for heavy goods vehicles in the first instance. Other countries as well in the Baltic, Latvia, Lithuania, equally have plans. Others like Romania, Macedonia, and then there are others that have question marks. Spain is planning to introduce a very large number of new tolled roads, about 14,000 kilometers, and we could well see that as the first country applying GNSS tolling for, or GNSS-based charging for all vehicles, light vehicles included. Similarly, There are ongoing studies in the UK, which is facing similar problems with a fiscal deficit because of the growth of electric vehicles. And then other places like Greece and Sweden as well, also looking into this, conducting studies, looking at both light and heavy vehicles, and how GNSS can be applied to charge them for road use. And then if we think about, again, there's been question around thick and thin clients. How are these generally applied in that context? Almost exclusively, there is a thin client approach across Europe where there is a GNSS system either in place or planned today. In some cases, that thin client component may be outsourced to a third party. I'm sure you're all familiar with the EATS market. Some countries will outsource that component to an EATS provider instead of processing the data, rating the trip, matching these data points centrally. But generally, the trend is towards a centralized thin client setup. And there are many reasons for that: cost, standardization, making sure everybody has the same experience and that the trip is charged exactly the same for everybody. And looking forward, we expect that trend to continue. We expect the likes of Denmark, Lithuania, and the Netherlands, who are due to introduce GNSS systems of their own, we expect them to follow this centralized thin client type model. Germany, as I've mentioned, already does. It used to outsource components of this to third parties, but over the next 24 months, this will be insourced in the same way that the Czech Republic, Slovakia, and Belgium all plan to do. So that's just a little bit of context behind how GNSS is currently applied across the continent. And in addition to that, we wanted to be aware of this issue of vehicle connectivity. Now, this can be defined in many, many different ways. You know, what does a connected vehicle really mean? And there are many ways you can look at this. You know, a vehicle has an infotainment system which has many, many forms of connectivity and touch points with the driver, be it through in-vehicle Wi-Fi, the audio-visual, the cockpit, which is becoming increasingly sophisticated. Everyone in Norway will know this, of course. It's like going to the future there. When you look at the cars on the roads, they all have 20-inch touchscreen TVs inside. That's an example of how this infotainment and the connectivity bundled with that is really growing. You also have a significant amount of what we might call telematics connectivity in the vehicle. That can be the cellular and the GNSS components that enable things like navigation in the vehicle. If you have, whether it's a Google Maps, a HERE, or a car manufacturer own brand navigation system, you will require a cellular connection and a GNSS component in order to see where the vehicle is and understand what the traffic conditions are coming up ahead. There's also, of course, this piece about smartphone mirroring. Now, 98% of vehicles sold in the world today, outside China, because there are restrictions on the use of Android there, but 98% of those vehicles are Android Auto and Apple CarPlay ready, and people really do use these things. That's using the connectivity of the smartphone to bring it into the vehicle and maybe supplement or add additional features that weren't there before. And then if we think further ahead, there's also this issue of vehicle to infrastructure, or V2X as it's known. Future components that will enable the vehicle to speak directly to infrastructure, or directly to other vehicles, or directly to the tolling station of the future. These are all forms of connectivity. And when we were looking at the concept of road user charging, what we could do, how we could do it, we wanted to try and leverage this connectivity as much as possible, for a variety of reasons that I'll go into. So that bit of background is really just to give you some of the things that we were thinking about when we approached road user charging for Norway. And we really had what I've defined as sort of 6 principles that defined our approach. You know, on the one hand, and this relates back to I think a question somebody asked earlier, you know, any system that we implement has to be as low cost and efficient as possible to both build, deploy, and operate. All of the existing taxes that we've looked at and charges are incredibly efficient to collect. You know, the fuel tax or the gas tax, if we want to call it that, is a very, very low cost tax to collect. And so we have to be aware of that. And of course, bringing in additional technologies will result in additional cost. There's no way of denying that. But we wanted to be cognizant of that and always be thinking about how can we keep this as low cost as possible. And things like using existing connectivity in the vehicle was one way we could do that. We need that solution to be flexible. Flexible in terms of how it's deployed. Should it be deployed to electric vehicles first or all vehicles? You know, we all know the road network is a living organism, and so the maps that we use and the roads that we apply this charge on need to be flexible. We also need to deliver the highest possible KPIs. Again, coming back to the fuel tax, that's incredibly efficient and has very little leakage. Back to the sort of wider context I was looking at, we wanted to make sure we were complementing and not conflicting with other solutions already out there. Whether we're talking about heavy or light vehicles, you know, we thought it's important that the solution that we trial here, that we look at in this proof of concept, needs to complement these and not deliver something that's totally conflicting, whether it be in terms of hardware or what happens in the back end. In the end, you will have Swedish, Danish, Finnish, German, whatever you like, vehicles driving into Norway. They will also need to pay a charge, and they may have charges in their own country, and they should be complementary in some way. Equally, the solution needs to be acceptable and easy to access for the end user. You know, whenever you bring in political change, there will be some resistance. That is inevitable. And so we are clear that what we want to deliver can hopefully mitigate some of that resistance by ensuring that what users get is acceptable to them. It's affordable for them. It doesn't bring additional cost for them. And is easy for them to interact with and to install in the first place. And finally, of course, we wanted to ensure that we had complete transparency, integrity, and security over user data. You know, when we're talking about any kind of GNSS related system, that does require the collection and processing of what many will justifiably see as personal data. And so we need to make sure that that data is absolutely secure, and users have complete transparency over how we're collecting that and what we're doing with it. So now just to get into the POC. So this began a couple of months ago, or a few months ago now, and we focused on the region in and around Oslo as a starting point. What we developed was a hardware agnostic Android application for smartphones and tablets. Today, that was used on smartphones and tablets, but again, the point of using a hardware agnostic application, or app in this case, is that today it's on the smartphone, tomorrow it could be in the vehicle, leveraging that telematics connectivity I was referencing in a previous slide. There's no reason you couldn't bring the app into the vehicle. Most new vehicles that are sold these days use an Android automotive operating system. Most vehicle manufacturers are moving that way. So there's no reason you couldn't just transfer the app from the smartphone into the vehicle, or use it in a mirrored way if you're using a Apple CarPlay or something like that. So we had a mixture of real world and simulated vehicles over this test period. And my colleague Nico will go into some stats of how many and how many kilometers we measured and that sort of thing. We had variable road user charges based on distance driven. So we didn't use a flat rate fee. We wanted to charge each different road class in a different way, and also implement a different pricing scheme depending on the vehicle that you're driving. All of the account creation, user consent, data terms and conditions were within the app. So this is where a user would interact with the service from the start, and where they would see all of the relevant terms, conditions, and other informations. And again, while there is the possibility to utilize things like the vehicle in the future, all of the GNSS locations and all associated data around things like the heading, speed that we used for this proof of concept were provided by the device, whichever device we used. And we used a whole host of different smartphones from different manufacturers, and also tablets, from extremely cheap ones to slightly less cheap ones, shall we say. Yeah, and again, we wanted to do that to show that we could use all sorts of different hardwares here. So the rating table was calculated by TWI, if I said that correctly, probably not, to reflect the existing fuel tax and also environmental costs. So as you can see, we ended up with a very detailed pricing scheme here, and one that had a very clear urban premium as well. One of the reasons we implemented this urban premium is because, again, sort of back to the question somebody asked earlier, what would be the cost of this? Now, absolutely, there would be an additional cost for this kind of system in future. It's not as easy and cheap as collecting a fuel tax at the pump. But what you can deliver with this is so much more. What a fuel tax can't do is impact or have an impact on congestion rates in downtown Oslo during rush hour. And there's nothing a fuel tax can do about that. But what you can do with a variable pricing regime is, as Paul was saying earlier, price different trips, put a different cost on trips, and try and encourage people to change behaviors, change how they view vehicular transport. Today, it's something we use for everything, but we need to communicate the environmental cost of this, the wider financial cost of things like congestion as well. So we wanted to put different pricing mechanisms that could address this. We had 4 vehicle classes, ranging from 0 emission to heavy diesel, and you can see the different breakdown for that here. Urban versus interurban, as I said, and also different time criteria. Again, if we wanted to in future influence things like driving behaviors and driving patterns, and when people choose to use a car versus a public transport option, time is a really crucial component of that. Rush hour is at a particular time for a reason. It's the same reason why current congestion charges in cities like London, Stockholm, and Gothenburg have different prices depending on the time, or are applied depending on the time. We also had some special policies in place with regards to the E18, which Nico will also go into next. And finally, just to go through, because we have our social media influencer / correspondent, Bjorn, up next, who's got all of the fancy videos and content. So I'll just show you a brief end-to-end process. But what we had was, as I mentioned, a user sign up through the app, consisting of inputting user information, vehicle details. We implemented an automatic stop or automatic start function on the app. This was optional, but this would enable you to pair the device with the vehicle upon entry, and then when you start the vehicle, launch the infotainment system, the phone would recognize that Bluetooth pairing and then start the JuztDrive app automatically. This, as I said, is an optional thing, but for sure what we saw as one of the drawbacks of using a phone is that you might forget to start it, for example, and this would mitigate that. Secondly, the app records positions as you're driving, can be operating in the background, doesn't need to be on the front screen like you would have a navigation system. And once recorded, these positions, packages were then sent to the Kapsch geolocation platform to be processed and rated on the back end. We would then match those locations to the individual road segments and then input the specific tariff depending on the vehicle and the location, and then send those reports back to the user to be shown as completed trips within the app with an attached price. We didn't collect any monies as part of this proof of concept, but there was a price attached to the trip. Finally, you know, this was a real partnership that we delivered. You know, we had multiple agencies or multiple organizations involved, and we each brought something to the table, and it was a really team effort to deliver this. You know, on the one hand, we had Aventi delivering the Android application, which was updated and improved and enhanced throughout the proof of concept. This was linked to what we call a central ITS server, which Bjorn will explain a little more about in a second. And then from the Kapsch side, what we delivered was our geolocation platform, which is essentially the back-end engine, should we call it, that is able to match the trips and price those trips according to these variable prices. What we did not deliver was things like a dedicated onboard unit and any asset management tool that might be needed to manage those devices. And again, what we didn't do is bring what would be a required back office component to do any billing and invoicing and customer support. We could do billing, of course, because we've calculated pricing, but we didn't do that for this concept. And then finally, another piece which I think is an open question for all road user charging pilots and proof of concepts really is how this is enforced. There are answers to this question, but again, this is not something we looked at specifically in this POC. And on that note, and hopefully on time, if my timer is correct, I think we have a little break, and then Bjorn will take you through with some videos really what this looked like in practice and how it was working.
Thank you so much, Justin. I think that break will go to questions. So as we're all sitting at home, so people can quickly go for a coffee as well. But I have some questions here that we would like to have some answers to. There's one, the first one, could you please confirm that road maintenance is not considered in the toll rates?
At this point, no. I don't I need to bring Paul back in for that, but I'm pretty sure we did not include road maintenance. No, not at this stage.
The external cost of road wear is there, but it's like for passenger cars, I think it's 3 öre per kilometer. So it's like the smallest component. It's larger for heavy trucks, but the marginal road wear cost is there, but it's the smallest component, at least for passenger cars.
Okay, thank you, Paul, for clearing that up. And then there's a question, how can you make sure drivers are using the app? How can you avoid smartphone to collect tolls for passengers if they have the app activated?
Yeah, so both good questions. I mean, how do you ensure people are using the app? Yep, it's not the easiest of questions. It's firstly something that has to be addressed through an effective enforcement regime. You would have to, of course, detect trips that were not being managed through an app or in vehicle application. How do you avoid collecting multiple tolls? Well, on the one hand, we might have a single pairing with the vehicle. Typically, most vehicles you can pair one device at a time, in which case that would start one device at a time and not several. We also looked at implementing a logic in the on the back end within the geolocation platform that would be able to pick up trips that were started and stopped at exactly the same time, and so we could identify when there were multiple or identical trips, and then we would filter those out. Yeah, if we had multiple, as I say, if we had sort of multiple common data sets from one vehicle, we would just simply filter out any duplicates.
Okay, and obviously the data question comes, which is good, and I guess several of the listeners are also thinking about that. What is the motivation for consumers to give away so much personal data, and nobody will trust it's only used as initially intended?
Yeah, I mean, trust is, trust can only come through clarity of communication, I suppose, you know, and that's really key to this. You know, it has to be clearly communicated what data is being collected and how it's being used. I mean, let's be honest, we all trust Google to collect our data today, and honestly, can any of us say how that's being used? I'm not sure I can. However, I trust them to, or should we say, I consent to that collection. I think here we can be very clear about what data is being collected, how that's being used, and how it's being stored. We would be very clear that it is not used, and there would be legal constraints built around this. You know, the inability to use this data for other use cases. There would be very strict storage limits put on the data. By communicating the trips back in the app, users would be able to see which data we have. So where they have traveled, they'll be able to see that yes, we have seen that you've traveled in these routes, and that can always be challenged if it's seen to be incorrect in some way. So I suppose, yeah, but back to what I said first, there are many components that need to be communicated, and really that trust just has to be built over time by making things very clear, putting clear safeguards in place. And ultimately, at the end of it, you will not be able to convince everyone, which is why there will need to be different choices here. Some people will choose not to use this approach, in which case you may need to implement something like a flat-based fee for those who are not willing to have their data used in a certain way, and that's fine.
And there's another question evolving around the area of excess data, too much data, or wrong data, and what do you do with if you're worried about the amount of data that you collect?
Well, I mean, I would say in terms of measurable volume, it's not as much data as you would think. As I was mentioning earlier, with the kind of wider context to how GNSS is being deployed, we already have around 5 or 6 million vehicles driving around Europe, which are sending exactly this kind of data to different locations in different countries. Norway, of course, doesn't come close to that number of vehicles, so I wouldn't describe it as excess data. It is data that is, would have to be processed that's not being processed today, but yeah, in overall terms, it's actually quite small packages that we send. You can measure them in bytes and kilobytes. We're not talking about megabytes and gigabytes of data per package. Very small amount, and again, that would only be kept for a certain period of time. So for sure, what we're not suggesting is collecting all location data for the rest of time. It would have very strict storage limits as well.
I'm sorry, I misunderstood the question from Oscar. He was asking more from a GDPR perspective and not the amount of data, where I was coming in from the size of it. So sorry about that. But we will hear from you a little bit later on, where you will touch upon the GDPR compliance. Maybe you can return to that question as well then. And as you said, we will hear from Björn and also see some of the videos, what's been done during the proof of concept and the testing. And therefore, Björn, hello and welcome. So if you can share your presentation, there you are, and the floor is yours.
Thank you very much. So I've been working on together with my team on the technical implementation of the Android app, and also the first half of the backend system. So here we can see the part that Aventi has been working on. So we have an app here, and it's sending the GNSS coordinates into this backend system, which is built on the same components that Netflix is using, Uber, and most car manufacturers. Collecting the data from the vehicles here, putting it into an event stream where we can process the data, and then storing it in a geospatial database over here. And then we pass on the data to capture a geolocation platform, and in return we get the price for this trip, and that's sent back to the vehicle. A more detailed view of the architecture is here. I'm not going to dive into all the details, but we had a lot of questions about the verification and enforcement. So we tried different methods here, all these weird little arrows here. So one enforcement method that we use is to compare the GNSS coordinates with the cellular towers in the area, because we have GNSS coordinates for those, and see if it matches somewhat the same location. We can also look at all the Wi-Fi hotspots all throughout the Oslo region and see if you're passing some of those on your trip. So that will be a nice verification. Here we have a vehicle OEM verification. We're using the vehicle OEM through smartcar.com, where we can actually get the API calls, where we can every 5 minutes check the GNSS coordinates of the vehicle that the vehicle OEM has reported, and we can also check the odometer, how many kilometers it's been driving. Here's how we start the app as another method to verify that you're in this vehicle. So we're using the Bluetooth MAC ID for the entertainment system to verify that this phone is in this car. And we have also a little test where we use an ODB2 dongle with a Bluetooth interface that you plug into the diagnostic port, and that will read out both the odometer and also verify that you're in this vehicle. I'm not going to talk more about this because I need to get to the video demos. So road use charge proof of concept. So we wanted to prove that you can use the smartphone to collect road use charges. So that's the focus on my part of the presentation. So I have some videos. Can you see this video now, Jenny?
I can.
Perfect.
Running and you're walking around the car.
Yes, good. So I will be talking on top of this. So here I'm sitting in the car, and I have my smartphone here, and I'm just going to plug it into the rack there. The road use charge app is not running, so I could have left the phone in my pocket if I wanted to, but then you wouldn't see anything. So once I get it fixed in the rack here, I will crank up the car, and when the car cranks up, it will. Here I'm just turning on the screen recording so you can see what I'm doing. So start recording. So that's how you get to see this this picture of the phone in the left side of the screen here. So there I crank up the car, and then we'll see if the phone starts when it recognizes the Bluetooth from the entertainment system in the middle here. And this works beautifully. I can also mention that once the app is launched, whether you have it in your pocket or up on the dashboard like this, if you want to run another app, Spotify for music or Google Maps, you can run that on top of our road use charging app. It will still collect the road use charges in the bottom. So now it recognized that the entertainment system had turned on its Bluetooth, so it connects. Now I click the start button. You don't really need to click a start button. It will collect your driving or your trip regardless. But for the sake of testing how much we pay for each trip, we implemented this start and stop button. Then I can drive the same trip several times and see that the cost is exactly the same every time I drive this trip, or different cost when I drive during rush hours or on weekends, and so on and so forth. So so now you can see there's a counter there, RUCPOC GNSS logging activity down here. It's storing the GNSS coordinates in a local file, and it sends it up every second, typically, if there's a good cellular connection. Now I'm at the end of the trip, and I need to click on the red stop button there. Click on red stop button. Yeah, I'm just talking a little bit when I make the videos. You can see these videos on YouTube, and there I end the trip. And now there's a start flag and a stop flag, and when I click on this plus symbol, I can go into the dollar symbol for the trip, and then it will query Kapsch's geolocation platform, and there we have my trip. There's some gibberish there with station IDs and stuff that we use for debugging and programming, but it costed 6 kroners or 0.6 euros. I can look at the map and see where I drove, and that's about it for how you use this app. And then several trips, they will accumulate on this page if you do several trips. Now we have to look a little bit on enforcement. So on this trip, I have one phone, that's my personal phone. That's an expensive phone on the left. And on the right side, I have a dirt cheap Lenovo tablet for 150 euros. On the right side now, I'm going to try to cheat the system. I'm going to spoof the GNSS coordinates by opening this mock location app, which I would never install on my personal phone because it's doing a lot of weird things. But here it's pulling up, and now I will try to fake my location. Maybe I want to try to avoid a special road or to get a cheaper trip. So I put in the start point of my trip here. It's a little slow here on the cellular. So I just hold my finger on the map, and then I put in a little start needle right there. There it comes. And then I go back to the Aventi office, which is on the other side here. And I'll plug in the end of my trip. And keep in mind, this is a fake trip. I'm not going to drive here. I'm just going to try to cheat the system. See if I can get away with paying my dues. So here I put in an end trip. I was building the route, and then it will bypass the GPS receiver in the tablet and instead report these coordinates. Now our app would actually decline these GNSS coordinates that comes from a mock location app, but we have put in a little debug flag that we can actually say that our app will accept it. Typically, people would spoof this with a separate GPS spoofer or something that they plug into the cigarette lighter in their car. But this is an alternative way of testing it without breaking the laws in Norway, because you're not allowed to drive around with those spoofers. There's some annoying ads in this app, so I just have to wait for those to play. They want me to download this app here. So now you can see that one of the cards are already starting. That's the mock location card. And meanwhile, I'll drive a legit trip on my phone on the left. So I will drive the upper road in a legit way where it says Haugenstua or County Road 163, and the European Road E6, that will be the fake trip. So we don't have to see the whole trip here. So I see if I can fast forward to the right spot about here. And then I pull over here. This is actually the Norwegian Public Administration's station right next to our office. I'm in a little bit of a hurry because the one on the right, the trip is almost done, and then it will suddenly make a jump. So I got to click on that stop button, and I'm only allowed to touch the tablet when I'm parked, according to Norwegian laws. So there I parked and click the stop button, and then I can find a better place to park. And soon you'll see that the tablet on the right is done with the mock locations, and I just flies over there where I'm actually located. So don't worry about that. And now I will pull up the same trip that I did in the last test. So first on the left side, I will have a legit trip, and on the right side, I tried to cheat the system. So I click on the plus symbol, and then I click on the $sign. And now it's going to be the second trip here on the left, because the first one was the previous test. On the right side, there's only one trip. The price is about the same. We did almost drive the same distance. So here's the map for that trip. So that's the upper road there. And on the other one, it's the lower road down there. So that looks legit so far, so good. But now I want to take a look at the behavior log, where we're comparing the GPS locations that the phone reported with the GPS or GNSS location of nearby cellular towers. So on the left side, you'll see in the map, I have 2 green dots. We do a check every 5 minutes, and both tests passed. They are says verified here. While on the right side, I have verified on the one on the bottom. That's the green one when I started the trip, because I was in the correct location. But then I tried to trick the system, and now it says that the cell tower scanning is not verified. I was not in the right location. So that's how we can detect that something's wrong. On the left side, you can also see that in addition, I have this Bluetooth media verification here. So I'm verifying that this phone is actually in this vehicle. So now I have a double verification going on there. Next demo. Now we are going to track coordinates in tunnels. So we picked the most tricky tunnel in Norway, I guess. It's the Opera Tunnel, downtown Oslo. So now here you see I have 3 Android devices. Same to the left and the right is the ones I used in the previous test. And in the middle, I have a Xiaomi smartphone, Android phone. It's really cheap, costs 120 euros. We bought it like a month ago. It does the one in the middle, at lower middle there, it does not have the screen recorder. So I can't show this fancy video, but I will put up some screenshots while I'm driving. So to the left, the left phone is very expensive, cost about 150 euros 3 years ago, and it has a very good GPS receiver. The one on the right and the one in the middle cost 120 or 150 euros each, and they have very cheap GNSS receivers. But they work. If I place the devices like I've done here on top of the dashboard, then the GNSS seems to work pretty good. If I put them on the floor, then I have more trouble with the cheap ones. That's something to keep in mind. So now I'm driving towards the Opera Tunnel. I'm turning into the Opera Tunnel right here. And now the GNSS, of course, there's the Opera Tunnel. Now the GNSS is lost. Usually your Google Map says GNSS location lost, and you can see they're bouncing around on the map of the central ITS server down there. So that's a little interesting. They are bouncing almost the same. So I wonder where that GNSS noise comes from. Anyway, now I'm out of the tunnel again. And now I'm going to drive back to the office and look at the charge reports and the maps. So if I fast forward here a little bit, yeah, that's another tunnel. So we had 3 tunnels on this trip, 2 really short ones, and then the long Opera Tunnel. So now on the left phone, I'll do the same trick that I've done several times. I'll click on the plus, but first I have to stop the trip. So we get the stop flag in and do some screenshots right there. I can put on the screen, and then I click on the stop for that one too. And then I can click on the plus symbol. You might wonder why do I sit and hesitate a little bit? Right now, this is a proof of concept. So it takes like 10-15 seconds to get the last GNSS coordinates uploaded to the backend system. That's why I'm a little slow before I click on the dollar symbol, but there we go. So now it's going to be the 3rd trip on that one, 2nd trip on that one, and 1st trip on the one that has a black background. You see that the price is the same for all of them. I should have emphasized that, so let me jump back a little bit. So I'll stop right there. So you see the price for this on the left, it says that trip was 13 kroner and 76 Norwegian cents. This one was 13.7 and 13.54. So it's pretty close. It's zero. It's just a little cents that are off. So we think that's pretty good for 3 different devices to come up with the charges for this trip to the Opera Tunnel. Now I'm going to look at how it logged the tunnel. That's the most important thing in this test. And here we see that it mapped the Opera Tunnel correctly, which goes from all the way from here, from Manglerud to Akershus Festning. All this is a tunnel, so it's really long. And all devices log this trip correctly. What you'll see is, I'm zooming in here on this. This is the charge object, so some concept that Kapsch is currently using. But if I turn off the charge objects and then instead turn on the show collected GNSS coordinates, then you'll see some blue dots. Let's see where that comes up. Here I turn off the charge objects. Now you see the actual blue line there. That's the actual GNSS coordinates. And of course, there's no GNSS coordinates in the tunnel. So you see a long stretch here from here all the way over here where there are no GNSS coordinates. Same with this one here. I enter the tunnel here, the Opera Tunnel, and then I've been driving all the way across the bay. So the way we then charge for the tunnels is the Kapsch GLP is doing the estimation here for where the tunnel is. So I think we're pretty much done with this video, and I'll jump to the last one. This one we didn't get fancy videos here, so we have some screenshots, and I tried to put together a similar test. So here is the this is using verification location using the smart car GNSS and odometer. So that's actually the vehicle OEM. So here I get the data from Tesla in this case. And So when I connect my phone, it'll ask me to connect through the smart car API, which in turn will go to the vehicle OEM. Here we have all the supported OEMs in our application because we use smart cars API. I click on the Tesla, and now I have to log in with the email and password that I have with Tesla to get access to the GNSS coordinates. So here we're driving. I don't have the GoPro video here, but we can see it on the central ITS server. And when I get around to the ending point here again, I'm back, and then we'll take a look at the screenshots. So here the verification is done not using the cellular towers, the behavior log, but it's done using the GNSS coordinates that we got from Tesla's backend system. Here's first the trip with the charge objects. And here we see the, let's try to stop it here. Here we see the verification. So I get the 2 green dots. It did it here, and then 5 minutes later, it did a check here. So both these times, it asked Tesla, what my app has its GNSS coordinates, and then it's asking Tesla, so what GNSS coordinates do you have for this vehicle? And if they match, then we'll say, okay, that's verified, and you didn't cheat the system. So that's it, Jenny.
Thank you so much, Björn. That was very interesting. We had one of the questions was we will share the videos as well with the PDFs and the recording, but maybe if you want, Björn, you would like to share the links to the YouTube videos already in the chat. That could be great. There's a question about there's one question here written that you've used the mobile app for the demo, but what about the onboard unit? And that you mentioned connected to the vehicle canvas connector. This is not required for the system to work, right? The onboard unit option is another connection option based besides using the app or for collecting extra vehicle information.
Yes. So I didn't. In this project we did not use a CITS onboard unit. We only used the app as a CITS device. So here it's just the app, and there's no onboard unit. If we wanted to connect to the OBD, which I didn't show a video for that here, we didn't finalize that implementation in this proof of concept, but it worked. So then we plug in a cheap Bluetooth OBD dongle for 30 euros here, and it's paired up with the phone, and that way we can get the odometer readings directly from the vehicle, and also the speed. Did that answer the questions, OBD?
Yeah, but if you were showing something at the same time when you were talking, then that wasn't visible.
No. Everything you saw was about.
No, you didn't. You weren't pointing down on a presentation. Well done. Yeah, question was answered then. Any other questions to Björn? We will obviously share also the videos as well. So thank you so much, Björn. He will still stay online. So if there are anything that you would like to hear from him, don't hesitate to ask in the chat. The next person to present for us more about the location platform is Nico Pfau from Kapsch. Welcome. And if you share your presentation, the floor is yours.
Thank you very much, Jenny. I'm sharing it right now.
Thank you.
Please let me know if you don't hear me clearly or cannot see the screen.
We can see it very nicely.
Good. So let me jump to my part. Welcome, everybody, again. Good afternoon from sunny Vienna. As Justin has already mentioned, we're sitting at the southern part of the building here, so it really feels like the middle of August since air conditioning is already turned off for energy reasons. But I hope I can take you through the next 15 minutes and try to have a look at the time here. Anyway, so I'm going to be talking about the geolocation platform, which has been already mentioned numerous times by now in the architecture diagrams and in the basic description of its functionality. The geolocation platform is basically, can I go to the next slide here, Kapsch's GNSS processing and road user charging platform. It's basically built around the concept of agnosticity when it comes to GNSS input, so it can function with a range of devices. These devices might be onboard units, which are typically used in heavy-duty vehicle tolling as of today. We're talking about usually a hybrid onboard unit here with the GNSS and DSRC for enforcement functionality. It can also work with third-party tracking devices. We're doing that today for nationwide tolling applications. In vehicle telematics, for example, the smart car API using Tesla data has been shown before by Björn. And for the purpose of proof of concept we're discussing today, obviously mobile applications. On the output side of the geolocation platform, it is also in a sense agnostic in the means, as you have heard from Justin today before, that we might have centralized charging schemes, which is an increasing tendency that we see in the market today. So the geolocation platform can enable tolling and charging on that side. But also, and it is doing that today, it can enable tolling applications in a service provider space and decentralized schemes. We already saw that significant amounts of data are processed here. Utilizing this data, GLP can enable use cases towards business, for example, fleet management applications, but also enable subsequent use cases in the spaces of traffic or demand management. Let's have a bit more of a detailed look, not overly detailed, but at least a little bit on what is going on inside the geolocation platform. Basically, in this POC, we use generic interfaces that the GLP is providing. These are built around the respective standardization that is in place today and in use for the heavy goods space, namely ISO 17475 for service provider internal communication and 12855 for service provider toll charger and communication. In a first step, what we did for the sake of this POC is basically source a version of the digital roadmap for Norway and more specifically Greater Oslo. We sourced this roadmap from OpenStreetMap, which you can basically think of as a sort of Wikipedia when it comes to geospatial databases. We then used the respective tariff table that has been presented by Paul from Toy before to automatically apply the charges that have been defined before to this version of the road network model. Then began what we usually refer to as the actual charging chain, which is ingest GNSS data from the mobile application via Aventi's ITS server, like has been shown by Björn before. When we speak about GNSS data, this is not only, but obviously also a latitude and longitude, but typically also metadata like the horizontal accuracy of the point, the speed, the heading, which can improve the subsequent results. This is optional data, which very much improves respective KPIs, especially in challenging urban environments, but GLP can also work without that. What we also receive there is charging relevant data. We have talked about vehicle classes before. So everything related to that is ingested via that interface. Then begins the actual data processing in a step which we refer to as map matching. So Orjan has talked about different approaches to GNSS processing before and how you can derive the driven distance from that. If you want to do that accurately, you usually want to, so to speak, relate the ingested GNSS data to a model of the real world, the model I described before that we ingested from OpenStreetMap, to get a precise view of the distance covered and the respective attributes of interest for the implemented charging scheme that are relevant. The next step is what we refer to as trip building. This then applies the respective tariff table as provided to us by Toy. We look at the distance that has been covered. We look, for example, at the different road classes that have been covered. We look at other charging relevant attributes, and we look at the respective input data that has been provided to us, such as already mentioned vehicle class, and we calculate the respective fee for that. In the last step, we distribute the result back to the CITS server and from there to the mobile application, so that, as Björn has showed you before, the result is directly transparent and visible to the end user. So let me briefly talk about some more technical stuff, and stay on a very high level. To enable these services for the proof of concept, we automatically deployed a specific so-called tenant for the sake of this process. We are using automatic deployments, which helped us enable this POC on a rather short time frame. We deployed the tenant to Microsoft Azure. I think I saw Austria on the slide before, which is not entirely correct. We have deployed to Northern Europe, actually, for the purpose of this POC. Also, Azure has services running directly in Norway since 2019, and basically enables GDPR-compliant data processing. Also, in terms of security, Azure is pretty much state-of-the-art when it comes to the investments they make in security and privacy, relevant R&D in terms of the number of people they have employed specifically towards these purposes, and when it comes to the number of certifications that are relevant in the space. Why do I want to mention deployment practices here? Well, because basically this enables us to react very fast and in a very quality assurance compliant way to respective changes that might be desired. These can, for example, relate to the road network itself. Justin has mentioned before that this is very much a living organism, which you will want to update on a very regular basis. Also throughout the POC, for example, we have extended the charging context that we have implemented to cover an additional area with very bad cellular coverage for additional testing purposes. So this you have seen before. This is basically the charging area that we implemented on the GLP side. This covers roughly 1.7 million hectare, or to make it a bit more understandable, and if my calculations are correct here, we're talking about 4 million football fields. If we zoom in here, we implemented so-called charging sections based on the underlying road network for the entire area. Basically, we took each road link and then applied the respective charging policy rules to that. We are talking about roughly a bit more than 300,000 links here. Link length is an average 135 meters approximately. If you're wondering why there might be slight gaps between some links, we excluded links below 20 meters, and we also excluded a run road class, as you saw previously in the table from time. Here comes again this table. Gonna be very brief around this. I think everything has been mentioned around respective rules. So GLP provides the basic measures to implement the policies that are desired by respective, someone said, I think, bureaucrats before, call them policymakers, call them society. So GLP basically enables, as has been said before, distance-based charging based on the road class, based on urban versus non-urban, based on weekday versus non-weekday, based on non-rush hour versus rush hour. In addition to that, for the sake of demonstrating the capabilities, we implemented special rules on the E18 between Oslo and Drammen. And they are not only for the stretch of the highway itself, but only based on the direction that the vehicle basically was taking on this portion of the road. So you can differentiate between city inbound traffic and city outbound traffic. Just an example of potentials that can be implemented in this way. This is what's going on in the backend in a more, so to speak, visible way. You have seen when Björn demonstrated the videos, the position that we received here. I can use a laser pointer here. As you can see, we use the sampling rate of 1 position per second for the sake of this POC. This is quite high for normal GNSS schemes. You would look at something between 5 and 10 seconds. But as you can quite clearly, I hope, identify, is how these GNSS positions become more dense in areas with low speed and get stretched out a bit in highway areas. And Norway, and in particular Oslo, presents quite a challenging environment for GNSS schemes. As you can clearly see, there are significant gaps in relation to tunnels here. So we've looked at the Opera tunnel before as in an example from Björn. So what the GLP now does is basically identify the roads that have actually been taken. You can see them now in red. And this is one of the test tracks that we predefined and then conducted, Björn conducted for us. And you can see that the gaps are closed quite nicely, even in a challenging environment, such as tunnels. Then I will point to Björn again. These are basically the respective single charge objects for which the rates are calculated. This is then what we distributed back to the CITS server to make it transparent and intelligible to the end user. We predefined, as I mentioned, some test tracks. The criteria for those was basically to cover a diverse range of of different road classes that we defined, of urban versus non-urban, covering the special rules that we applied, covering all the vehicle and time classes that we applied, and basically cover a diverse, challenging test set. We pre-calculated the fees that were to be expected for these routes, and Björn, as you have seen in the video before, then drove these tracks with numerous devices in the vehicle attached. Initial results were pretty good. We're talking about 99.5% accuracy here. As you can see, marked in yellow, there were some exemptions. These were mostly resulted to challenges also visible in the videos before when it comes to very bad GNSS accuracy. So we have the typical effect of positions jumping around at the entry and exit of tunnels. The Opera tunnel is a particularly challenging example here, where you have this gap in the middle. And we basically applied some improvements on the front end, filtering out positions by the respective horizontal accuracy. After applying that, KPIs were around 99% accuracy. It needs to be said that these systems are never deterministic, but neither are these RC or video systems. So you really want to be judged by respective KPIs. Good, I see Jenny already coming up there, so I'll try to hurry up. These are some more examples of from left to right tunnels in quite dense urban environments, tunnels in rather low cellular coverage non-urban environments, roundabouts in dense residential areas. And to finish off, some general statistics for the time of the POC. So while the project overall started a bit earlier, the deployment was live in July, where testing started. The main part took place in August, and then basically through October. Overall, we processed roughly 18 million positions. The main portion of that coming from simulated test data to stress test also the system in terms of horizontal scalability. When we're talking about these systems, we're talking about potentially processing thousands or millions of vehicles in parallel. We map matched 2 million kilometers overall, and we're looking at roughly 25,000 distinct devices on the peak day here. It might seem that we did nothing on the other days. This is not the case. As you can see, especially Björn was quite active. Obviously not as comparable in load as to the main peaks, but this was, as you can see here, the testing that was carried out through the rest of the time. And that's basically it.
Thank you so much, Nico. Are there any questions to Nico while he's here online? You can either send it on the chat or ask directly. I guess the accuracy becomes a big question moving forward when we talk about positioning. So I think that's something like when Paul started his presentation, he was on the trust issue, and then the accuracy comes more being more focused.
Yes, absolutely. So you typically look at so-called over and undercharging in GNSS schemes. You absolutely want to avoid overcharging typically, because this is just unfair, obviously. Then again, also within this POC, all the results were immediately transparent to the end user. So you have the hardest possible auditor in place, I would say. But obviously also from a business perspective, you want to avoid undercharging. As said, these KPIs, I would say, are quite high, and also compared to other schemes, as I've said before, you typically do not have deterministic schemes in place also for video or DSRC-based tolling applications. One advantage of a centralized scheme would basically that everyone is processed through the same system. So as opposed to a decentralized scheme where this might differ.
Thank you so much, Nico, for that. We will share his presentation in a PDF format also after the webinar. Next in line, Justin, you are back again, and you have a couple of more slides about the GDPR compliance.
That's right. So we're now coming to the end, and for those of you who have stuck around, we appreciate it. And as you can see, we left the most exciting topic till the very end. And I promise I have done my best to make GDPR compliance as exciting as I possibly could. And to do that, I have animated my slides. But more seriously, I think when we talk about this issue of data integrity, GDPR compliance, which we already have a little bit, it is at the same time extremely complicated and extremely simple. And here I've taken more the simplified approach, also because of time available. We did conduct, as part of this POC, a very thorough investigation in partnership with a dedicated legal firm who specialize in not just GDPR issues, but also any issues to do with connected vehicle data use, and there are all sorts of different directives around this, such as the e-privacy directive, the ITS directive. There's also specific bodies that specialize in connected vehicle data and use. So back to, as I said earlier, the way we look at the data element is that every party's role and responsibility requests are very clearly defined and communicated, and ultimately, beyond everything, this system and any system really rests on the consent of the user. If we don't have the consent of the individual user, then obviously nothing is collected, then the system is not working. That's clear. What we are not talking about here is taking data where there is no consent. That is not what we're talking about. We very clearly defined three specific parties, should we say. On the one hand, we had the data subject, and that is the person who is driving the car, and it is their data. They are the owner of the data. We then have the data controller. This is the person or entity who is determining how that data is processed and by whom. In this case, the example would be Aventi. Aventi would be the data controller as the issuer, should we say, of the app. Then finally, we have the data processor. This is the person or entity who is processing the data, sometimes on behalf of the data controller. These are the clear different roles and responsibilities we defined, which is also based on our legal analysis and understanding of all the respective directives. And each of those parties has a responsibility at a different point in the process. So the data subject, of course, is providing the most fundamental and important role, and that is consent, giving us consent through the application, where before anything has started, there is a very clear description of how the system is collecting data, what data it's collecting, who the data controller is, who the data processor is. That would be very clearly communicated, and then a user would choose to consent or not based on all of that explanation that we give them. Aventi, of course, as the data controller, is responsible for collecting the data in the first instance, sending it through its central ITS server to Kapsch as the data processor. Maybe just as an additional point, when the data is processed, the geolocation platform, which is the processing engine, does not hold data around the identity of the user. What the geolocation platform sees is a unique identification number, and this is a randomly assigned number which corresponds to a device and therefore a vehicle. So during this data processing phase, what is not happening is that we see Nico Fau has traveled from A to B. That is not data that is held in the data processing piece. What the data processing piece does is see that device 1, 2, 3, 4, 5 has traveled from A to B. And then, of course, on the other end, when the data is sent back, again, to the responsibility of the controller, Aventi in this case, it is then displayed transparently to the end user, so they can see exactly what the data that we have collected looks like in the real world. In this case, on a map, they can see exactly where we are saying they have traveled from, and they can challenge that if it's deemed to be incorrect. Maybe just to answer the previous question as well around taking too much data, if I remember correctly, or the wrong kind of data. We only request very specific data to make this process work, and that is things like longitude, latitude, direction, and speed. They're very clearly defined parameters that we request or call, and nothing outside of that is shared, because nothing outside of that is requested. As I say, this, because it's based on user consent, we are then adhering to all of the applicable legislation. The integrity of this data was fundamentally important to us. Of course, underpinning all of this, there has to be some sort of legitimate purpose and a lawful basis, and other aspects that I mentioned earlier around, for example, how long the data is held, would be defined as part of the kind of lawful basis of this scheme. So there would be clear ground rules and legal definitions around how long the data could be stored, and perhaps even where the data could be stored. There would be regular auditing processes to make sure that this data is only being used for that process. And as I said, we would only collect the data that is fundamentally necessary for what we need. And anything else, we simply don't request and we don't process. How we comply with this, various ways. Obviously, most of these processes rely on machine-to-machine interfaces and automated decision-making processes. So once those legally defined processes are put in place, it's then simply running exactly as it should. We have also looked at kind of excluding the first few moments of when a trip starts and a trip stops. This is something that could be employed for this scheme, for example. So not charging the first, let's say, 30 seconds of the trip and the last 30 seconds. So if you wanted to add additional safeguards, you would then not be able to see, the system would not be able to see where exactly the trip started and ended, because that data would be excluded. So you could have additional kind of safety or guarantees, should we say, by implementing measures like that. Again, just to add, the data would only be stored for the purpose of appeals by the user. The user would be able to see in real time where that trip has taken place, and the only reason we store that data is in case they want to challenge that determination. There is no other reason for storing this data at all. Yes, there would be potential additional use cases for use of anonymized data. So for things like understanding where traffic patterns, where is congestion and at what times, but this can be done in a fully anonymized way. And again, this is optional should the relevant authorities wish to look at this kind of information as well. Yeah, and that's the very kind of simple take on this. There is a longer 36-page document that we have. I'd be happy to go through with anyone. But as I say, on the one hand, extremely simple. User consent based on very clear, well-defined roles, responsibilities, and actions. And that was it from me.
Thank you, Justin. I think that, as you said there, that subject is something that requires a kind of a webinar on its own. So we will come back to that at a later stage, because that requires a little bit more into-depth time. But I would like to just quickly, before we close down, and also to the audience that is still there, and thank you for being patient. I know it's a long webinar with a lot of material, but we thought we have everything in one instead of just trying to divide it up, as it still has a red thread. So thank you for listening for so long. But where would you go from here? And when you've been listening to these, both the starting point and also from Kapsch and Aventi, are there any ideas that falls into your mind that could actually be in addition, or just something different? And that we would love to hear. Where would we go? Where would we go from here, as from your perspective? I would like to ask if Örjan Tveit, if you're still there, about how do we get, what's the next step? Do we just wait for the government to make a decision from the results that has been coming out, or is there something that we, meaning we collaterally, both public and private, and ITS Norway also can help with to continue?
Well, for start, I think that the initiative from Kapsch is something that is done by Kapsch and Aventi themselves. So they see the potential. I also showed a figure that showed that other interest parties are also moving forward. So I think that for the industry, this is something that's coming either in Norway or another European country within a matter of time. So to be in position, I think is important for the private companies. For the public authority, we need to follow the procedure, I think. The public road administration will not start this feature just on its own.
Now that would be highly unlikely, that I understand. But on the other hand, you welcome also more tests from the industry as a general, just to see if there are other concepts that we haven't looked at.
Yes, as I mentioned, we are currently focusing on GNSS, but we have also looked at mobile solutions for 5G to see if that's possible, just to rule it out or see if it's possible. So we are still looking into that direction.
Mm. There was an interesting comment here by Adel from Kobla, also about the increased ride sharing in the future, where we want to, and where we might be going. The car ownership is so expensive, you want to share your car with others, and have you taken that also into the consideration?
I think that carpooling is something that's possible to slice up, because then first you have the car and then another one has the car, so there's a time discrepancy between it. But when it comes to carpooling, I think that's something that you also have problems with a gasoline pump price currently. It's a taxation that lies on the car and where it's travel. So I think that we can do something, but not everything.
I will give the final word to you, Justin, because you're on the screen there. So lucky for you. Then where do you
turn my camera off?
Yeah. Where do we go from here?
Yeah, I think I mean, I think there are several important next steps. One is very short. You need to start building trust, and that has to start by involving real people. So I think next steps would be involving real world users in this, starting to communicate how specific systems could work, getting real world feedback, and also implementing different choices. So as we were discussing at the beginning, we're running a kind of GNSS variable pricing proof of concept here, but there also needs to be some sort of static pricing concept that runs alongside that for people who do not want to use let's say the tracked method. So I think it's about engaging with people, always having more than one option, because one size is not necessarily fits all. Yes, and some other things as well, which
I'm sorry to rush you through there, Justin, but I like to keep my time, and I'm already 1 minute over time. But I think this was a very interesting, very to the point, and this time right presentation. We would really want to hear your feedback, and also we would like to hear if there's something that we could continue discussing and talking in other forums. We would love to do that, and we will share, as I said initially and wrote in the chat, the presentation. So if you would like to have the PDF, send me an SMS, an email, not an SMS, an email. My email address is in the beginning of the chat. And I would like to thank everyone that presented from TOI, the road user, the NPAR, the Kapsch and Aventi for putting this together, and look forward to seeing you all again soon. Thank you so much and have a lovely afternoon. Bye-bye.
Thank you, everyone.